Why isn't this thing recorded? Okay, can you see my screen now?
Yes, sir.
Okay. So here we're gonna have different types of reactions when it comes to acid and bases. So the main word here is a salt. So a salt is a neutral ionic compound that composes of a cation and anion, which is a result of an acid-base neutralization reaction. So basically, when it comes to neutralization, our products are going to be a salt and water, just as we can see with a strong acid and a strong acid, where you're going to have hydrochloric acid reacting with sodium hydroxide. That's going to give you sodium chloride and water. Same as here. So these are salts. So usually when neutralization occurs, your products are gonna be a salt and water and sometimes carbon dioxide. But that just depends on the reactants. But it's mostly gonna be a salt and water. So here they're just telling you about how acid-base neutralization is used in our daily lives. So they say it's used domestically, it's used biologically, it's used as in the industry at antacids. So I don't think they're really gonna ask you guys about how this thing is used, how neutralization gets used in our daily lives. Hazard. So what's the next reaction? So here now, this is where we're gonna come to the pH scale. So when calculating pH, we're gonna use two concentrations. One for the proton, which is, and one for hydronium. So pH measures the acidity and alkalinity of a solution, or the acidity, or I don't know how do you say this, base, how acidic or basic a solution is. So these are the two equations that we are gonna use for pH. So pH is the negative log of the concentration of the proton, or negative log of the concentration of the hydronium ion. And here, these two equations down here are gonna be important because it's not always where you're gonna have a proton and a hydronium ion as a product, as the products of a reaction. So sometimes instead of the hydronium ion, you can have the hydroxyl ion. So what you should know is that the concentration of the hydronium of a hydronium ion and a hydroxyl ion, when they, the product of the concentration of a hydronium ion 3O plus and a hydroxyl group, that's gonna be 1 times 10 to the exponent negative 14. Same applies if it's a proton and a hydroxyl group. So 1. So basically, the equations that you need to memorize are these, but they'll probably give you these in the back of your question paper, and these two. They won't give you these two equations, so you're gonna have to try it and memorize them. And this, most of the time, they're gonna write it in the form of POH, which is gonna be equal to your pH so your POH is gonna be equal to 14 minus your pH. So if in a particular reaction they give you the concentration of OH, you can use this formula to find the pH still by using the concentration of OH and not using the concentration of the proton. So here we have our pH scale and our concentrations. So we're gonna have our strong acids where the concentration of the proton is 1 times 10 to the exponent negative 1. So basically, if you look at it, the concentration of the proton decreases when a solution is becoming more basic, and the concentration of the hydroxyl group increases when a substance is becoming more I'm sorry, the concentration of the proton is gonna decrease when something is becoming more basic, and the concentration of the OH is gonna decrease when something is becoming more acidic, when the solution is becoming more acidic. I just hope that you keep that in mind. So Kw is the ionization constant of water, and your Kw is equal to the concentration of the hydronium ion multiplied by the concentration of the hydroxyl ion, which is 1 times 10 to the exponent negative 14. And here they're gonna give you a few constants, because Kw at 25 degrees Celsius, that's 1 times 10 to the exponent negative 14. And they tell you that the concentration of the hydronium ion and the proton at 25 degrees Celsius is constant at 1 times 10 to the exponent negative 7. So if they're gonna give you guys a question and they say that it's at 25 degrees Celsius, which is mostly room temperature, you should know that automatically the concentration of the hydronium ion or the proton is 1 times 10 to the exponent negative 7. So here we have some simple rules about strong acids and weak bases reacting strong acids and bases reacting with weaker or stronger bases and acids. So when a strong acid and a strong base react, a neutral salt is going to be formed and water is going to be formed. So same as here. And the pH of the solution is going to be 7. So the solution is going to be neutral. So when a weak acid and a strong base react, a weak base is going to be formed and water is going to be formed. So the pH is going to be above 7 because a weak base is going to be formed. So the solution is basic. So when a strong acid and a weak base react, a weak acid is going to be formed and water is going to be formed. So same as here, the pH is below 7, showing that it's acidic. So basically, if you know which are your stronger acids and which are your weaker acids, same applies to the bases. You can be able to estimate the pH before you actually attempt to answer the question. Because if you know that it's a strong acid and a strong base, you can estimate that the pH is supposed to be somewhere around ±7. And if it's a weak acid and a strong base, you know that the pH is going to be above 7. And if it's a strong acid, if it's a strong acid and a weak base, your pH is going to be below 7. And if it's a weak acid and a strong base, your pH is going to be above 7. I hope that makes sense. And these are some indicators that I used. So I think, yeah, I think there are